In this section, what we're going to do is we're just going to revisit the shelf tool a little bit to kind of see what some of the possibilities are. I'm starting here in my build desktop. I'm going to, as usual, hit the D key with my mouse hovering over the viewport. I'm going to go to turn off the origin gnomon and make the background dark. Not totally optional on your end. Just want to do this because I think it'll make the video a little bit easier to see. All right, cool. So regarding the shelf, basically on the left-hand side, there's a bunch of sort of modeling and rigging tools in general that tend to be helpful when, you know, sort of working with stops and you know, some constraints work, etc. By all means, explore these shelf tools for sure. As well as on the right, we've got more things that are related to rendering and simulation in general. We've got, you know, Vellum, which is basically cloth and Houdini 17's new cloth and soft body standard, particles, just collider objects, grains, you know, fluids, viscous fluids, some ocean tools. We've got, let's see, you know, fluid container tools, other options for filling those containers in more, pyro, which is like explosions and all sorts of like, you know, smoke type, volumetric simulation. Finite elements, which are, you know, sort of another way of doing soft bodies, which we won't really cover, you know, in this course. We're going to mostly focus on Vellum because that sort of it's a lot faster and more user-friendly, in my opinion. Wire solver, crowd systems, you can build crowd systems off the shelf, and just other simulation drivers. A lot of this stuff is really cool. I mean, over here we've got, you know, terrain effects. You can build, you know, do like landscapes and stuff like that, and, you know, hair grooming utilities, all that kind of stuff. So for our example, I want to just show the power of the shelf and how the shelf can be used as sort of a starting point or a cheat sheet into some more complicated effects. So we're going to melt a cube. And I think that, like, at this point, probably melting a cube, you know, we haven't even started to cover dynamics yet, but I just wanted to kind of show that you don't really need to know, you know, every last thing about dynamics in order to get something going. So let's do that. We're going to just start by throwing down a box. And that box is sort of floating around at 0. I'm just going to dive inside and do the little trick that we did in the expressions lesson, which is using the side. The size in the Y dimension. I'm going to right click, copy the parameter. And then I'm going to paste relative reference into the center Y position. And that just pops it up by the height of the cube. And since we only want it to go up halfway, so it rests on the floor, I'm just going to divide it by 2. So if that seems new to you, I would just go back and take a look at the expressions lesson and make sure all that relative reference stuff is working out, is making sense in your mind. Also, I've got a little pop-up here prompting me to save my file, so just bear with me for a second. I'm going to go and do that. So I'm going to save it here and hit accept. Awesome. Okay, cool. So now we've got our box, and let's turn this into a melted object. So I'm going to hop back out to my object level, and I'm just going to go over to the viscous fluids tab up here. And I'm going to click Melt Object. And that just quickly sets up a flip simulation for us. I'm going to, because it's dropped us into our Autodop network, this layout is a little bit messed up by default. So I'm just going to hit the L key while my mouse is inside the network view. And that just does its best to try and lay out those nodes for us. So yeah, this is the DOPS context, or the dynamics context, where you do dynamics operations, or DOPS, and it has created this for us on the fly while we are using this shelf tool. So it took the box, it made a dynamics network, and then this is where it processes the simulation of the particles, and then it brings those back out into the box fluid so we can turn it into a mesh. We'll touch on that a little bit later. I'm just going to turn in the flip fluid object. I just want to get the particle separation down a little bit so that this is, oops, I'm going to use a value of like 0.025 just so that it's a little bit more dense and we can see what's going on. So if I hit the play button right now, you can see that gravity, which is in our scene which is in our dynamics network right here, is pulling our box object down in space, and it's just falling in free fall. So we'll just add a floor collider to make it so that it can kind of rest on the ground. So I'm just going to go over to the collisions tab here and choose a ground plane. And the ground plane comes up. It's got this symbolic, sort of arrows that are pointing off in each direction. That means that even though you can see the geo of the ground plane here, it's visible, or it's gonna interact with, everywhere where it is in Y. So if we jump in here, you can see we've got our ground plane geometry, and then if we go into our DOP network, it's added these nodes off to the right over here. I'm just gonna hit L again. And you can see it's thrown down our ground plane, and it has sort of, merged that into a static solver and then merged that into our simulation. So cool. So if I go back over here and zoom, oops, I'm gonna hit spacebar F in this view to frame my nodes. I'm gonna hit spacebar F over here to frame my scene and just kind of zoom in like so. So now if I hit the spacebar, you can see that we've got sort of this viscous blob that starts falling down, and then the color starts changing orange because it is cooling off due to this field that was created inside the DOP network. We are going to, let's just make this a little bit more solid so that it actually appears to be a solid object that starts melting, sort of like an ice cube. So I'm going to go over here to this gas temperature update, and you can see that your minimum viscosity and maximum viscosity are set to these two values. I'm just going to crank up the maximum viscosity by adding, let's say 3 more zeros to the end of it, so it gets super solid. Now, if I click play, you can see that it just falls like a, fraction of a centimeter, and then it just more or less is sitting there. To increase the visibility of what I'm doing, I'm going to just grab the ground plane and just untick display proxy geometry. I'm going to hop back out to the object level and hide the ground plane object. So even though we don't see the geometry of this object, we can still enjoy the effects of having a ground plane and seeing how all that works. So there we go. Everything's good. All right, so now what we want to do is melt this. So let's create a little field that we can use to kind of determine where the melting is going to happen. I'm just going to throw down a sphere like so. And let's just, I'm just going to grab these guys and put them underneath here. Kind of like to go in order. So I'm just grabbing all of these, holding down A, clicking the top one and dragging down to align them. And because the ground plane, the box, and the sphere are all going into this network, and then that network is outputting into this final geometry box fluid. I just kind of like to keep things in order. We've got our inputs above our dynamics network and then our outputs below it. So simple. I'm just going to grab the sphere and let's just reposition it a little bit. I'm going to change the size of it down, and I'm going to just bring it, let's say, let's just go like maybe like that. So we're just melting the corner of our object. But we need to set this up to melt because all we've got in here is just a sphere. So I'm going to go up to the viscous fluids tab on the shelf again, and I'm going to say heat within object. The way that this model works out is that it is when objects are hotter, they become less viscous, and therefore, if we are to heat within the sphere object, it's going to make the viscosity drop inside of this object and appear to melt. So I'm going to hit the heat within object. Now down here, it's giving us this select fluid object to heat. I selected my my particles here, and then I'm just going to hit enter again. And you can see that it's sort of turned that sphere into like a little fog. And so if we go back to our object level, I'm just going to turn off my grid. Go back to the object level and dive into the sphere. It's created some nodes for us. One of them is a flip source node, and it's creating a volume, temperature volume, that is, going to be creating some heat for our simulation. And now if I were to go into my DOP network, you can see it's added some more nodes here, like this heating volume over here. And that's where it's sourcing in our temperature. And if I just hit play here, you can see that this area gets white hot, and it's starting to melt these particles away. So if I go, I'm going to hide this output for a second. I'm going to grab the sphere, and let's just do a little bit of animation. We're going to just, let's keyframe the position of the sphere here, and then let's go out to like frame 48 and just have it move maybe through the box diagonally, something like that. I'm also going to just bring up the scale of the sphere a little bit so it's a little bit more dramatic. And here I can see, because of the colors of my fields, I haven't actually set another keyframe, so I'm just going to option click translate again to set that key as well. So you can see our melting field is going to go right through our cube like that. Actually, I'm going to offset it a little bit more so that it isn't initially intersecting. So I'm bringing that over here. I'm going to hit this arrow to move to my next key, and I'm just going to bring this off to the left a little bit more. And if I preview that, it looks like it's going to go all the way through our cube and then clear it. Awesome. So now I'm going to go back to frame 0, and let's go into the DOP network. And here I'm going to just hit the play key, and I'm going to hide the other objects in my scene just from this drop-down menu up here. And actually, I kind of do want to see that sphere. So I'm going to ghost other objects and just hide the box so I don't have to see that. But I can see this volume sphere. All right, so back in here, I'm just going to hit the play key and see what happens. You can see that this sphere is moving through that cube and just sort of gouging out a nice little area that it is melted within it. And you can see the temperature on this. Now, what this gas temperature is doing behind the scenes is it's cooling everything off. As as we've added temperature, it's still going to cool and then sort of harden here and stop melting eventually. I'm going to call that good for right now. Yeah, you can see that it's sort of coming. Now, if I play this back, because of this blue bar at the bottom, it's sort of cached it out. We play that back, you can see we've sort of started to melt a nice little, kind of canal through the middle of this cube. So I'm going to hop over here now. I'm just going back up to the object level. I'm going to hide everything except for this box fluid output import node. So if I dive inside there, you can see that it has set up this network for us as well using the shelf, which basically imports our geometry, our particles, from the DOP network, and then it kind of blasts away some other fields, copies some attributes around if we want, like, it looks like it's transferring UVs and all that kind of stuff. Then what we can do at this point is we can compress the fluid, save it out to a cache, and then come over here and then we can surface it. So I'm just going to highlight this surface node for right now, just so that we can kind of get an idea of what it is, what it's looking like. And I'm just going to turn on from up here the smooth shaded so I don't have to see the wireframe as well. And then I'm just going to kind of play this back a little bit, see what it kind of looks like. Now, it's not going to play very fast because it has to remesh this frame, but I'm just going to play that back using a flip book. So I'm going to say down here in the lower left-hand corner, there's this little flip book icon. I'm just going to hold down on that and say flip book with new settings. And it's going to go by default over our render frame range, which goes all the way to 240. I'm just going to cancel this out and have it stop at frame 72. And then I'm going to click start. And what it'll do is it'll kind of crop this out. It'll open up a copy of mplay here and just start playing back whatever the viewport is doing, and then saving a little video clip of it so we can look at it. So just going to let that go for a second. And now it's gotten to the end, and if I click the play button, you can see we've got our object melting here. Now, it's not like the most amazing sim I've ever seen. I would obviously want to do other things to this, like crank up the resolution, figure out maybe a little bit more interesting of a heat temperature field to apply to it, something a little bit more random. But you can see that just using some basic shelf tools, and I've only tweaked a couple parameters, we're really kind of rolling with kind of a cool melting setup with very minimal effort. So that was just sort of like a revisiting of the shelf tool to sort of demonstrate what power is in there, and really encourage you to explore building some setups using the shelf tool. It'll actually kind of serve as a little bit of a guide as to what sort of these background processes are for setting up nodes and caching out your simulations, and how to set up a simulation even. If you wanted to study this, and eventually you could figure out how to set up your simulation from scratch by looking at simply what the things are that the shelf tool does for you. And I use it all the time, even though I like a lot of, even though I'm pretty comfortable setting up most Dynamics networks, I'm always going to the shelf trying to figure out how is it that side effects is doing something. And if I, just click a couple buttons of the shelf, it's all laid out for me. I can reference it. I can pick it apart. I can hack it together with my own setups. And, it's just a really great starting point. So that was sort of the quick revisiting and demonstration of the power of the shelf. And then in the next example, we're just going to do a quick Cinema 4D and Houdini comparison. So I will catch you in the next lesson.